Have you ever stared into the night sky and wondered about the vastness of the universe? It's a question that has puzzled humankind since the dawn of time. The universe, with its awe-inspiring expanse and countless celestial bodies, is a mystery that beckons us to explore and understand it. In the grand scheme of things, we are but tiny specks in the cosmic canvas, yet our curiosity and thirst for knowledge propel us to delve into the depths of the cosmos. This quest to comprehend the universe and its origins is the crux of cosmology. It's a science that acts as our cosmic compass, guiding us through the labyrinth of the universe, helping us make sense of the celestial chaos. From the swirling galaxies to the twinkling stars, from the radiant suns to the silent voids, every element of the universe is a piece of a grand cosmic jigsaw puzzle. And cosmology is our attempt to put these pieces together to weave a narrative of the universe's birth, evolution, and eventual fate. Speaking of birth, it brings us to the predominant theory explaining the universe's inception, the Big Bang theory. This theory paints a picture of a universe born from a singularity, an entity of infinite density and temperature. Around 13.8 billion years ago, this singularity exploded, giving birth to space, time, matter, and energy. It set the stage for the cosmic drama that has been unfolding ever since. The universe, as we know it, began with a Big Bang, but that's not where the story ends, or rather begins. The Big Bang theory explains the aftermath, the cosmic evolution post the explosion. But what about the prologue? What led to this singularity? What triggered the explosion? And the most intriguing question of all, what was before the Big Bang? But what led to the Big Bang? And what was before it? This is where we venture into the realm of the unknown, the unexplored. It's a mystery that continues to perplex even the brightest minds. And it's this enigma that we'll attempt to decipher in our cosmic journey. Let's delve deeper into the mysteries of the universe. To understand the universe, we first need to comprehend the Big Bang theory. Now imagine a tiny, infinitesimally small dot. That dot, according to the Big Bang theory, contains all the matter in the universe. Quite a stretch for the imagination, right? But stick with me. Around 13.8 billion years ago, this dot started expanding rapidly in a hot explosion, a phenomenon we call the Big Bang. It's not like a regular explosion you might picture, with a center and fragments flying away. Instead, it's the expansion of space itself. Every point in the universe is moving away from every other point. Now, you might be wondering, how do we know all this? Well, the evidence is quite compelling. First off, we have the cosmic microwave background radiation, or CMB for short. The CMB is the afterglow of the Big Bang, leftover heat from that initial explosion. It fills the entire universe and can be detected with a sensitive radio telescope. Next, we have the redshift of distant galaxies. As light from these galaxies travels to us, the universe expands, stretching the light waves along with it. This stretching shifts the light towards the red end of the spectrum, hence the term redshift. The farther a galaxy is, the more its light is redshifted, indicating that the universe is indeed expanding. Finally, the distribution of elements in the universe also supports the Big Bang theory. In the early stages of the universe, conditions were just right for the formation of light elements like hydrogen and helium. Today, these elements make up about 98% of the observable universe, just as the Big Bang theory predicts. So there you have it, the Big Bang theory in a nutshell. It's the best explanation we have for the origin of the universe, based on the evidence we've gathered over the past century. The Big Bang theory gives us a starting point, but what about the end? What's the ultimate fate of the universe? Just as the universe had a beginning, it may also have an end. As we navigate through the cosmos of theories and hypotheses, let's ponder upon three main theories about the potential end of the universe. First up, we have the Big Crunch theory. It's like a cosmic game of boomerang. The universe, which has been expanding since the Big Bang, might reverse its course and start contracting. Everything, from the farthest galaxies to the smallest particles, would be drawn back into a singularity, the point of infinite density. Imagine stretching a rubber band to its limit and then letting it snap back. That's the Big Crunch for you. Next, we have the Big Freeze or heat death scenario. This theory suggests that the universe will keep expanding, but at an ever-slowing rate. Over trillions of years, stars will exhaust their nuclear fuel, galaxies will drift apart, and all matter will decay into its most basic components. It's like the universe is a cup of hot coffee left on a windowsill, gradually cooling down until it reaches the same temperature as its surroundings. Lastly, let's visit the Big Rip theory. This is where dark energy, the mysterious force causing the universe to expand at an accelerating rate, gets a bit too enthusiastic. If the expansion becomes too rapid, gravity wouldn't be able to hold galaxies, stars, planets, even atoms together. Picture a piece of paper being torn apart, not just into two, but into countless pieces. That's the essence of the Big Rip. Each of these theories presents a different endgame for our universe, an unthinkable finale to a cosmic performance that's been running for almost 14 billion years. But as we contemplate these mind-boggling notions, we can't help but wonder, are we alone in this cosmic theater? While these theories are fascinating, they also raise another question. Is our universe the only one out there? Let's delve into this intriguing question in our next segment, the multiverse theory. Imagine not one, but an infinite number of universes, each with its own laws of physics. This is the premise of the multiverse theory, a concept that not only challenges our perception of reality, but also offers tantalizing answers to some of the most profound questions in cosmology. Picture this. Instead of a single universe, there is a multiplicity of universes, a multiverse, where each universe is a distinct bubble in an infinite cosmic ocean. These universes could be vastly different from ours, with entirely different physical laws, or strikingly similar, with just a few variables tweaked. The multiverse theory stems from the field of quantum mechanics, which deals with the bizarre and counterintuitive behavior of particles at the smallest scales. One interpretation of quantum mechanics, known as the many worlds interpretation, suggests that all possible alternate histories and futures are real, each representing an actual world or universe. This theory has profound implications. For instance, it could potentially solve the mystery of why our universe appears to be so finely tuned for life. In a multiverse, every possible combination of physical laws could exist somewhere, so it's not surprising that we find ourselves in one where conditions are just right for our existence. Yet the multiverse theory is not without its critics. Some argue that it's more of a philosophical concept than a scientific one, as these other universes, if they exist, would be impossible to observe or interact with. Others point out that it seems to complicate things unnecessarily, violating the principle of Occam's razor, which suggests that the simplest explanation is usually the best one. Despite these criticisms, the multiverse theory remains a compelling concept that continues to captivate scientists and laypeople alike. It pushes the boundaries of our understanding and forces us to reconsider what we think we know about our universe and our place in it. The multiverse theory is a mind-bending concept, but it's not the final frontier of cosmological exploration. As we continue to delve deeper into the cosmos, who knows what other mind-boggling ideas we'll encounter? The journey of discovery, after all, is never ending. The universe holds secrets that are invisible to us, secrets shrouded in darkness. Two of these secrets go by the names dark matter and dark energy. Now, dark doesn't mean they're evil or ominous. In astronomy, dark simply means that we can't observe these phenomena directly with our current tools and technologies. They're like cosmic phantoms, revealing themselves only through their effects on the universe. So, let's delve into dark matter first. Imagine you're looking at a galaxy. It's spinning so fast that the stars at the edges should be flung out into space, but they're not. Something is holding them in place. That something is what we call dark matter. It's a kind of gravitational glue that holds galaxies together. But what exactly is it? Well, that's one of the biggest mysteries in cosmology. Some scientists think it might be made up of undiscovered particles, but for now, it remains an enigma. Next, let's turn to dark energy. You've probably heard that the universe is expanding. But did you know it's also accelerating? That's where dark energy comes in. It's a mysterious force that's pushing galaxies apart, causing the universe to expand at an ever-increasing rate. But just like dark matter, we're still not sure what dark energy actually is. It's another cosmic conundrum waiting to be solved. These two unseen forces, dark matter and dark energy, make up about 95% of the universe. That's right, everything we can see, stars, galaxies, and all the matter we understand, accounts for just 5% of the cosmos. It's a humbling thought, isn't it? We've barely scratched the surface of cosmology. The universe, it seems, has many more secrets waiting to be discovered.